Hi, my name's Irrelevant, and today I'm gonna see if I can fix this power supply. Alright, so this is a buddy's power supply here. He uses it to run his RC chargers, and it is not working at all. And it also seems to be covered in shmoo. He said he had a Loctite explosion. Now there's a good chance I'm not going to be able to fix this thing, but I'm going to look inside it anyway and see if I can find something obviously wrong. Stuff like this, once it's gone, and it's kind of beyond my pay grade to fix it. I'm very handy with the tools, but some stuff is just like, I don't know how to test for blown transistors. I feel like we have to go in from the side. It looks like it took a nice dent right here. Maybe that has something to do with it. There's like all sorts of different kinds of screws on this thing. Obviously, I'm not the first person to be working on it. All right, we need more keys of Allen. What key opens this lock, you tell me? This key. Oh, one side, okay, maybe does something there. Gonna have to pop the other side. We got a top that comes off now. Oh, looks a bit ugly in here, but it also looks kind of simple too. And it smells like burning. Oh boy. That might just be cigarette smoke. This guy likes to rip a lot of darts. Okay, it looks like this entire thing's gonna slip out. Let's look underneath. Oh boy. Yes, we had a disaster right here. Look at that. Bzzz. Blown right the hell out. What's this here? Ah, it looks crispy right there too. Yeah, something got overloaded here. The trace got burned right off the board. Now, why would something like that happen? And what are the chances it didn't take the component with it? Very unlikely. That connects to one of the MOSFETs here. I'm assuming they're MOSFETs. That's commonly what's used. I don't see any burn holes in those. Capacitors look good. Let's tack that wire on and see what happens. We might have some damaged resistors right here. This diode's still good. Yeah, that diode's still good. How's these resistors doing? That one has signal. That one has signal. That has signal. Testing random diodes all throughout. That solder joint looks sketch there. Now, where's the fuse on this thing? Fuse is right here. Oh, fuse is still good. Maybe that's part of our problem. The fuse should have blown, but it didn't. I don't really see anything else damaged on this. Wonder if this thing's actually so basic that it doesn't have basic overload protection built onto it. All right, let's see if we can improve the state of this affair here. Oh, look at that. There's just this blackness here. Like, what is that blackness? Well, we seem to be getting underneath of it. Almost looks like this coil could have came loose on us. This terminal right beside it, it looks not too good either. Maybe that's what happened. Maybe this coil came loose. You never know. Sometimes things just come loose and it takes other stuff with it. Okay, those should be on there nice and good now. Can we see anything else sketchy going on in here? Oh, yeah, look at this coil connection. Oh, it's moving. Completely blown, sir. That's my expertise. I'm not the most skilled technician in being able to diagnose a circuit. I'm just really damn good at soldering. I understand tube circuits, but not a lot of solid state circuits. This solder joint here sucks too. We're gonna fix on that. I don't like that solder joint. I don't like that solder joint. That one looks a bit nyeh. This one looks like crap right here. Same with this one. And this one. So, this compromised position right here. Can we glob that over enough? It burnt the trace right off the board. A lot of that going around lately. I'm probably gonna have to bridge that with a solid piece of wire. All right, so here's a scrap piece of 14 gauge solid copper wire. That should have plenty enough capacity for this particular circuit. Kind of get it held into place there. And now we douse it. It's not holding it in place so good, sir. Certainly got on there though. And we have to connect it to that pin there. Oh, we're just floating in solder now. Okay, now we have to nibble that off. Can I see anything else wrong in here, sir? Anything else? Oh, look at the glob on the paper where it was. It looks like there was a loose, either that is solder that melted off that contact, or maybe there was something loose in here. Okay, so we need to steer well clear of these 120 volt contacts back here. And these rails, they can get hot. You don't want to be touching these rails, just in case something blows up in my face. You ready for this? Oh! 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 That was fun. Ooh, that smells nice. Whatever it is, it sure smells good. Waff. What sparked this time? My solder joint stayed into place. Oh, there's another bad solder joint over here. I'm just grasping at straws here now. Oh, the fuse burnt this time. Try testing on this a bit. So Mr. Fuse over there, she's gone. D13009K. What's a D13009K? D13009K is a very large high power transistor. So got a wattage rating, sir, or an amperage rating, 12 amps, collector current, 12 amps, 24 amps pulse, base current, 612. Well, if I bypass that fuse and try to jack her up again, what's gonna happen? Probably not good things. Oh, okay, I'm seeing disaster. Yeah, if you look on the back of this thing, she's a little screwed. There's a nice crack in there. Yeah, there's a chance it was like that before. Actually, there's a very good chance it was like that before. That's the reason why it failed. These things probably blew and short-circuited, took out the trace on the board, and then when I fixed the trace and forced more power through them, it just... Ah, man. More torque than brains! Oh, yes, let's pinch our hand meat. Let's get that screw out of there. I'm getting white schmoo all over my hands. This one looks visibly damaged, too. Come on. Just let go. Just let go, bud. Oh, yeah. Look at that blowing out there. Pshaw. These are no good. Now the question is, do I have any little replacement, like, what the heck could I have in inventory that would have a component like this on it? I don't know that modern power supplies, like the good ones like computer power supplies, are going to use this kind of method of doing things. I can go look. Lots of the newer style power supplies, they use, you know, like MOSFETs, these little puppers right here. And they are much smaller. And they're also switching. They don't do passive regulation, they use PWM regulation. None of those will do. This much older power supply's got some large blocky boys inside of it that look similar, but I don't know if it's gonna have, oh yeah, it's got two matching ones, or it looks like it could. Now can I get a part number off one of those before I spend the time ripping it out? LRFP460A. IRFP460A. IR. N-power channel MOSFET. Yeah, no. I doubt I can just swap in a MOSFET in the place of a friggin' power transistor. You do think that is a very good idea, sir? There's some nice beefy MOSFETs though. I need to remember that they exist. There is a time in the past when I would have been more experimental, be like, let's see if we can shoehorn this into there, but I might just set this aside. Like, what would it take to get a couple of those? Let's go on eBay and see what comes up. They're not particularly expensive. Looks like they're easy enough to get. They're all shipping from China though. So, speed pack. Narrator, there is no speed. So just for the lulz, I ordered a pair of them off eBay for like $6, $8. In the meantime, because I have this power supply here, a computer won't recognize it. So it's got a bad power OK signal. However, if you don't know how to jumpstart a power supply, it's actually quite simple. You look for the green and you short it out to a black. Well, that didn't sound promising. It made a squeaky noise. Are we getting power out of it? So that's the idea. Sometimes you get old power supplies that the computers don't like anymore, but they'll still put out like power. Oh, this one's not. Okay, no, this power supply is done. At least that gray one I had before. It just needs some caps. Or maybe this one has the power transformers we need. Power transistors. Maybe it has the power. Oh, it's got some beefies. D209L. Oh boy, I just wasted money if this works. Hold up here. CBE, 12 amps, 400 volts, 12 amps, 400 volts. Oh boy! It's also a 350 watt power supply, so similar range. I didn't even have the fan on this hooked up. I've already worked in here. All right, how's this coming out? Very destructively so, I'm afraid to say. Ugh, puffy capacitors. More screws for the hardware department, yeah? And we got some IAC jacks and stuff out of the deal. Oh, as if I'm getting white schmoo all over everything. I need snippers. Give me the snippers. Snip, snip, snip. All right, where are these beautiful bean footage? Loosen up the heat sinks. We gotta get those unscrewed first, because they're not gonna come off at the same time together. Oh great, these guys are glued too, aren't they? Rah! All right. Whew. I can get these screws out here. I should hold on to these thermal pads, and now we must unsolder these components. Gotta get the solder all moist. There we go. That is one. My soldering iron just turned off. I feel like I'm in the twilight zone here. I'm not getting any thermal. I'm just burning myself here. Okay, come on now. Come on. There. You let go, and you let go, please. Both of you let go. Well, that's what happens when you're half-assing it, right? Alright, so these guys, to the best of my knowledge, are healthy, and it's quite possible that they're compatible. Alright, where's our circuit that we're trying to fix up right here? Burp, burp, burp. Oh, there are thermal pads on this already. They had thermal pads and thermal goo. They're double whamming. Okay, kind of sorted that. Kind of sorta sorted. What's next? Make sure those holes are clean. Those holes are totally not clean. Let's get this guy open. Let's get this guy open. Oh. See if I can get him into place. This section is really blown out here. Almost to the point where I don't understand where that was supposed to connect to. It connects to this resistor bank. Same as over here. Are those resistors also damaged? Because that would be inconvenient. Oof. You know what I think they are? They almost look like they have holes blown in them. And that's making it impossible to read their value. 5 something 1. And according to the meter, they have a very high resistance right now. And there's no similar resistor on the board. And they're in parallel. 2 5 something 1 resistors. I almost feel like it says 5R1. 5.1 ohm and 2 in parallel, that's like 2 ohms. Half hour till dinner time. Am I gonna get it done by then? 5R4 could be current sense. That's the only reason why I would think they'd have a resistor that small. Like if that value is honestly at low, 2 ohms. Well, I say 2 ohms because it's two 5R4s in parallel. And two 5R4s in parallel is going to give us half, so 2.5 ohms. I just noticed more sketched out solder joints. I think I'm eating out again today. Let's see if we can get these stupid things into place. What are you doing? That's not where the hole goes. Get into the hole, bud. Wow, that was fun. People tune into my YouTube channel, find out I'm actually quite incompetent. Are you into fitness? Yeah, fitness component into place. Here. How are we gonna get at this one? That angle's all wrong. Side screw it? Yep, side screw it. Okay, let's tack them down. Oh, I need that little piece of Ron Weasley back. And by Ron Weasley, I mean the friggin' wire to link it back up. Now we need to solder push this like that there. Hey, what'd you expect to happen, bud? You let go of it. Let go of the stick. Don't give him the stick. Except we have one more terminal here. That's back into place. So, those blown resistors equating to a total of 2 ohms. Oh, where do I get some SMDs that size? And I need 4 of them. Unless I can find something in the 2 ohm range. 2R5? Hello, is there 2R5 out this? I got enough donor boards, that's for sure. I still need to bridge this connection here, actually. Oh, not like that. No, not like that. There. They're connected now with just a case of getting power to them. There's a 2RO. That'll work in a pinch. Can you give me another 2RO? Come on, buddy. I know you wanna. 2R7. That's close to what I need. Ah, 2R7s. I found 2R7s. I'm gonna need Grandpa's glasses. I don't actually wear glasses, but these things allow me to see stuff that's real close. Like everything's blurry now. But then once I start looking closer, oh yeah. I might have too blunt of a tip on for, I lost them. Oh, no, there's one. Come on now, buddy. 2R7. Get shown. This is always the most daunting of tasks, getting these tiny little puppers off here. I think there's even a layer of conformal coating over this guy, so it's kind of like glued on there too. There we go, that's one. Now let's see if I can get this directly onto this board. So the idea is I'm replacing two 5 ohms with a 2 something ohm, because 2 5 ohms in parallel is 2 something ohms. So I'm just gonna like hack and slash schlup that in there. You probably can't even see. I don't know if I can zoom in enough. Right there, we're just straight up hacking that in there. Like doesn't even. This is I'm a hack. Oh, I have an idea. Because this is so screwed up, we'll use this to re-establish the linkage. Grab onto that, push her into here. Yeah, so that's that side connected, and then the other side's right here. I got too blunt of a tip on right now. Okay, that's one in place. Now where's that other 2.727R on here? I've got it. That's basically the extent of my tech skills. Find things that are blown, replace them. If I can't find the thing that's blown, well, too bad. I'm in a position here now where I need several more hands. Or hands that aren't covered in thermal grease. Alright, that's one side. There's the other side. Now, is there any other sketchy solder joints? Why is this wire disconnected? Well, that's interesting. What was that wire connected to? This center post here. Okay, well, it's another thing I'm gonna have to put back. At least I could tell, buddy. There's a chance that this thing blew up because it's just was shoddily put together. Too many loose solder joints. Too many things come to loose. Now what am I gonna do about this blown fuse? Where is it? With fuses, I don't have a lot in stock because they blow. Oh, what's our value on this fuse? 6.3 amp. Of course, that's a value that I don't have and need. Here is a 7.5 amp automotive fuse. I don't expect this to last very long. I'm just gonna go ahead and paste it onto the bottom of the board here. This might seem very unprofessional, but it's skills like this that are gonna allow you to survive the wasteland. Real hacking skills. Okay, we have to get a bridge from there to there. I've got thermal compound on my fingers and it makes these things slip every time. All right, fuse that on there. That's one, that's two. All right, that's fused now. All right, attempt number 2. Make sure nothing's touching that's not supposed to be touching. It's funny when you're expecting an explosion, you can't help but get somewhat apprehensive. At least there's a fuse on it. So we got that all back together now. It's probably gonna friggin' explode again. Let's be honest. I'm not expecting miracles here. And oh, we got fan spin. Okay, hold on here because we don't know if this is about to overload and freaking go nuclear. How are we looking in the voltage department? 13.9. Well, frig. All right. This fan sucks brutal donkey balls, but all right. That's interesting. Quite the delay turning it off. Let's put this guy back together. Those components on order are kind of useless now, I guess. Now, these fans, how are they oriented? That one is suck. That one's blow. All right, that makes sense. You see these aluminum rails, it's like they should be touching the sides nicely, but they is not. So how that heat manages, well, I guess they're kind of touching the sides. Just finish going in there. Just finish going in there, bud. All right, now we have to put on the Overlord. Oh, this was made by Venom. I don't know who that is. Maybe that's something to look out for. A Venom fault. A faulty Venom. Slide it on. And now this side. Unfortunately, these don't use goofy screws, so they're gonna go on right away. Alright, now if everything went according to plan, we plug it back in here, sir, and it won't blow up. Oh, ugh. This isn't exactly 350 watts, but it's 18. It's just me or these fans move like no air. I feel like there's improvements I can make to this. I need to find something I can hook up to stress this out, like a bigger light bulb. I need a bigger light bulb. I have these 28 volt 150 watt light bulbs here. That's not 12 volts, so that's probably, they're gonna be running at half their wattage, so we'll say 150, 75 watts. Urgh. There we go. We're probably putting a 150 watt load on it right now. Ah, I'm feeling heat coming off the chassis. I'm also smelling suspiciousness. Maybe this thing's just not cut out for it. Or maybe that smell is just all the horrid crap that blew up in it before blowing itself out. Do I have a way to confirm that it's actually 150 watts? Yeah, I do. Oi! Well, there it goes. Well, that was rather experimental. We had it, and then we lost it. Oh, yeah, that smells ripe, bud. Can we see what went here? Like that sounded amazing. It doesn't look like what I just replaced. It doesn't look like the puppers on the other side. Okay, well, it is getting late now. I want to be done with this, but you know, we just can't leave it there. We just can't leave it there, especially after all the work I've invested into it. Isn't that just disappointing? Sometimes things just get worn out and that's it. You can spend a lot of time trying to find out exactly what. And I really would love to have left this video on a high note, but it doesn't look like that's gonna happen. Oh, our fuse went. I don't really see traces reburned. That's funny. I wonder if the fuse just popped. That fuse popped and maybe arced out, and can I tell what was stinking? Not really. Maybe this thing just can't handle it. I don't know what to say. Could have been a piece of crap that... Okay, so just to confirm something here, now that the power supply's not under load, let's see if it'll turn on. No. It's a good thing I don't have arc fault on this particular circuit. This is the reason why I don't have arc fault. I have GFCI in case stuff gets wet, but I don't have arc fault. No, it's just had it. She's done. All that work for nothing. It's like I said at the beginning, it's unlikely that I'll be able to fix this thing. I'm surprised I got as far as I did. There's a good chance that if you use this continuously, or you continued to use it for a light load, it would have been fine, but no, it's not having it. 150 watts, freaking popped her again, and she's good as done. I didn't damage my nice needle nose, did I? I thought I should maybe use something else. Oh well. More experiments in the mad scientist laboratory, seeing if we can resurrect the dead, but unfortunately, not today. Not today. Now the funny thing is, I do have another 2 of the transistors for this on file. Maybe we could do this all over again. I don't know. Either way, I gotta call it. I am hungry. It is past dinner time. Yeah, let's... Thank you for watching. It's a simple enough circuit. Like, I'm sure there's lots of people who can figure this out. Whatever. That's enough.